Hey guys, and welcome back to Maths with Cats. So we're going to go over some more stuff for binomial expansion today, specifically infinite sums. So what happens if n isn't a natural number? Well, if n is a negative number or a fraction, the expansion becomes an infinite sum. So we need a new equation. So in this case, it actually is the exact same equation, but the modulus of x must be less than 1, and n must at least be real. So here's an example. Find the binomial expansion of 1 over 1 plus x squared up to including the term in x cubed. Well, this is the same as 1 plus x to the minus 2. So n is a negative number, but that's okay because n is still real. It's not natural, so modulus of x has to be less than 1. That's all it means. So you do the same thing, sub it into the same equation, and you end up with 1 minus 2x plus 3x squared minus 4x cubed. When I say same equation, I mean the same equation as the one we went over in the last video, which I'll link. Okay, here's some more examples. Waiting for it to load. Okay, find the binomial expansion of the square root of 4 plus 3x up to including the term in x cubed. Square root of 4 plus 3x is the same as 4 plus 3x to the power of a half. We need the first number to be a 1 for our equation to work, so we're going to take out a factor of 4. So we have 1 plus 3/4 x, and the 4 is also included in the to the power of a half. You can take out the 4 to the half and get 2 lots of 1 plus 0.75x to the half. Then we're going to put the 2 outside some square brackets, and we're going to start expanding it all using the same equation. So we're going to have 1 plus 0.5 lots of 0.75x plus a half of a half minus 1 over 2 lots of 0.75x squared plus a half lots of a half minus 1 lots of a half minus 2 over 6 lots of 0.75x all cubed. You can then simplify all that and you get 2 lots of 1 plus 3/8x minus 9 over 128x squared plus 27 over 1024x cubed. Expand that out and you get 2 plus 3/4 x minus 9 over 64x squared plus 27 over 512x cubed. Now, what are the limits on the x values then? So if n is positive, a plus bx to the n is valid for all x. If n is negative or a fraction, a plus bx to the n is valid when bx over a, the modulus of that, is less than 1. Here's an example. Find the first three terms in the expansion of 1 plus 2x cubed over 1 minus x squared, stating the range of x for which it is valid. So this is the same as 1 plus 2x cubed lots of 1 minus x to minus 2. Then we can expand them out. So we get 1 plus 6x plus 3 lots of 3 minus 1 over 2 lots of 2x squared. We're only going to go up to the third term for each one because the end result is only going to have the first three terms. And that's going to be times by 1 plus 2x plus minus 2 lots of minus 2 minus 1 over 2 lots of minus x squared. Times them, so simplify each of them. 1 plus 6x plus 12x squared lots of 1 plus 2x plus 3x squared. Multiply them together, and we only want the first three terms, so we're going up to the x squared term, and you get 1 plus 8x plus 27x squared. So 1 plus 2x cubed, so the first part, is valid for all values of x as n is positive. The second part, 1 minus x to the minus 2, is only valid for the modulus of x is less than 1. So the overall thing is only valid for the modulus of x less than 1. That is the end of this video. I hope you found it useful. Leave some feedback in the comments below. Like, subscribe if you did find it useful. And I will hopefully see you in the next video. Bye bye!